Hey there, myself Krish Rajakuram, very warm welcome to all. And this is day 20 of Foundation AI series. And in this day, we talk about a little bit probability and conditional probability. So overall, probability matter very it's matter very most when we're talking about artificial intelligence. At the end, at the end of the day, artificial intelligence all about generating response, and that response is all about prediction. So probability matter to just generating like your LLM models is basically generating a text. So that cases it's need to just predict the word, the billions and trillions of the words. Okay, and after this prediction, they use the probability method to just predict that all this particular word, what the next word will be. So probability matter. So overall agenda for today, that first we discuss for today, like the first one is like intro to probability, we look toward the importance of basic of probability, what should to know at what is the probability is and why this particular probability is important for us. And secondly, like conditional probability, we focus on specially one specific type of the probability, conditional probability. And that basically that the that use cases of conditional probability is very high in the LLM and all the particular models of the artificial intelligence. So we do according to it again. And so that's all about for today. Again, if this particular video is going to productive or if you learn something from there, then it's my pleasure. So let's get started. Hey, let's come to agenda number one. And in this agenda, we actually discussed about the probability, what exactly probability is, and how can we understand the probability. So let's start. So when we're talking about probability, probability is all about when in lots of scenarios that we have uncertain knowledge and lots of chances to a particular outcomes. Now suppose you are going to solve any kinds of the problems, so the possibility of getting answers have a different probabilities, different chances, and you have uncertain knowledge. Uncertain knowledge is all about have lack of understanding, lack of knowledge over the entire process. Okay, so you only expect that kinds of the outcome this particular outcome may have some kinds of probability. So in fact, if I say you about this probability is a way, and I think I will give you a two different word, actually two easiest word, two magic word, which actually help you to understand about the what the probability is. And the first one is like uncertainty, and second one is chances. So in lots of scenarios, in real world scenarios, like we actually have uncertain knowledge. Okay, so now suppose you want to solve a problem again, and you have an uncertain knowledge, it's of a lack of knowledge, you don't know what's happened next. Okay, and there will lots of different chances of the outcomes. Now suppose uh, outcome A have different chances, like 80%, 90%, and outcome B, outcome C, so lots of different chances. So when we are dealing that kind of situation, we need a probability. So probability is all about the number which express the uh, outcome in their mathematical form. Okay, by exact giving a, if you want to, if you give an exact number to represent their particular outcomes, now particular you suppose in any actions. Okay, it's all about you can say A, B, outcome A and B have different probability, but you, when you just represent this, when you label this particular outcome with the such kinds of the number, that you can say that's probability is. So the number which express the outcome called probability. So the mathematical way to express a outcome, that chances of the outcome to fulfill your uncertain knowledge, okay, is called the probability. Okay, so that's the actually probability is. So okay, so now suppose again we take the example like action, some kinds of the event, and event have different outcome scenarios like the A and B and C and D. So there were four different scenarios when you're looking toward there, and when you just give a different numbers to just adjust all the particular one to so that how actually its outcome will be likelihood. Like when you give a number, exact definition of the number, which actually define their what is the what is the chances of the A and B. Let's suppose A have 20% chances, this one 30%, and again this one is 20% and this one is 30%. So that's the basically a number which actually uh, represent that the how the particular outcome will be. Okay, at the next. So that's the basic way, and that's the called probability. So in that case, we deal with the uncertain knowledge. We have a lack of knowledge what the next happen, and there were lots of different chances. So that's why we need probability. So that's the called probability for solving that uncertain knowledge and different chances and on different scenarios. We actually deals with probability. So that's called the probability. Okay. Okay. So that probability is, and we're talking about the probability. So probability is all about mathematical expression, as we know, but probability have some range. Okay, so it's not only for bigger digit 10, 11, 12, 13. It doesn't matter. Okay, probability work, the range is like binary range. For example, 0 to 1. So probability have a range 0 to 1. If the probability of any event, okay, is 0, then you can say this is impossible event. This is never going to happen. Okay, and if this particular event have probability is 1, then it's a sure event. Okay, so it's going to happen, very possibly likelihood. Because of that, this is the very possible event, like 1 stage that 100% probability, and 0 state at 0% probability. And if the anyone, if the any of them between lies between 0.5, 0.8, that means 0.80% probability. So probability scale is all about 0 to 1. So it's always lies on the 0 to 1. Okay, so all the numbers lies on, that's the 0 to 1, how actually it's lies on the 0 to 1. Always particular probability scale is lies on probability outcomes. You give a number, okay, A, B, and C and D. So different outcomes have a different number. So the probability of a scale of each of the outcomes will be lies between 0 to 1. Is it 1? Is it 0, 0.5, 0.6, and so on. So that's the particular probability is. And let's come to discuss about basic rule probability that you should to know about when you just moving forward to the race of artificial intelligence. That's the basic important part to discuss. The first one is basic rule of probability, like component rule, addition rule, and multiplication rule. So it is like something different, but I will try to connect this all respect to one. Component rule states that, uh, now suppose probability of in any event and probability of any event A, probability of any event B is equal to 1. Not A, sorry. Probability of A and probability of not A is always 1. Okay. In that case, you can say if you want to find out the probability of not A, okay, then you just shift this particular one with that. That component rule states that you can move this LHS and RHS from understanding much better. So that's the component rule. And second one is addition rule. Addition rule is all about, I will give you a brief description around it. Addition rule is all about something you can say, uh, it's all about just adjusting all, it's all about stage diet, stand for, and you can say it's stage diet. Any particular event, okay, any two event not occur at the same time. Now suppose you toss a coin, okay, you toss a coin, and the probability of getting both outcome at the same time is not possible, head or tail at same time at one single coin. But when you just throw a different coin, okay, in different scenarios, that the possibility of the getting a same outcome is likely possible. Okay, but in that situation when you toss one single coin, that possibility of getting head or tail at the same time is likely not possible. So that's the call addition rule. So that's addition rule stays right. Okay, say right. So basically addition rule say that like mutually exclusive, that means if the two particular one is like not happen at same time, then you can say uh, this one is like uh, it's look like something, you can say a different one. Okay, in that case, two particular event. Now suppose uh, probability of A or B, that means either A or B. Okay, so it's look like something. in that both scenarios, probability of A and B is equal to either A or B. Okay, so in both events, I think only one event will be possible. So that formula says that only. Okay. Other like overlapping event, so it's only for overlapping event is all about something you can say. In some scenarios, this particular one is not possible when event at a two event at the same coin is not possible. But when you toss two different coin, okay, and the possibility of getting a same outcome is possible, so that's the call overlapping event. And in that particular event we can say that uh, this particular one is possible. Okay, so it in fact we can cover this particular overlapping but like shared outcomes. Sometimes it is possible like two when you toss two different coin, that sometime it's possible to getting a same probability, same outcome at the same time is possible, like head or head. So that's the overlapping event is. So that's the additional rule, and it only say that like something uh two event occur at not same time, either one or b. Okay. And last part is multiplication rule, and that multiplication rule is all about something you can say is all about when you want to find out two or more different outcomes, okay, two or more different events probability, then you can use this particular one multiplication rule, and it's look like something. And this is the particular formula like ye and we just find out this more probability. Okay, and just you need to just do it this, it's all work like conditional probability. And I will try to connect this conditional probability with this particular multiplication rule in the next part. And let's move forward. Let's come to their particular part. And in that part we discuss a little bit about conditional probability. And actually this is what that's very matter when you're discussing about artificial intelligence especially. uh, Conditional probability is really necessary to discuss because of that this particular one is actually interesting concepts. Okay, and that were lots of real world application based on there, like Netflix recommending system, Google search based on that kind of this particular one, and ChatGPT is also based on. So I don't think so like only for one particular puzzle of the this is a part of the puzzle of this particular recommending system and Google search engine, but it's also contribute to a role in that case of the recommending context and artificial intelligence. So conditional probability is important to discuss. So that's why conditional probability is important to discuss. So let's start with the conditional probability. So when we're talking about conditional probability, I'm not going to give you like 100 word context to explain you in that particular definition. Just I give you the three important word which actually define the entire concept of conditional probability. The first one is like dependency, and second one is the given and likelihood. So it's all about, now suppose you have two different outcomes. Okay, now suppose of two different events A and B, then like if the particular like how much the A dependent to B, if the particular, now suppose you have the five different scenarios. Okay, if one changes, then what the probability effect over there remaining four. So that's the basic one, like how much the one effect over the other probability. So that's the conditional probability. So now suppose okay, so now suppose you have the five events. Okay, and one events, if you just change the if you know the one of the out of five event, then what is the probability of the next one? Okay, next five, next four, remaining four. Okay, so that's the exactly probability is conditional probabilities. Just you know out of five one of them, then how can you predict the next one? Okay, how remaining four. So that's the actually probability is conditional probability is. So it is all about dependency of given likelihood. So out of all this particular context, out of all these particular scenarios, how much the one of them, if you know one of them, then how can you predict the next remaining four or more? So that's the particular conditional probability. So it's all about dependency. You are just find out the dependency, how much they are likely dependent from other one. Okay, so that's the probability is the conditional probability dependency of given likelihood. So you have a different likelihoods and how much this particular one is dependent from B. So now suppose A, B, C and D, this will different scenario. If you know this one, this particular one, then what will be the probability of this one, this one, this one, remaining three? So that's, you know, out of four one of them, what the remaining probability of the three. So that's the particular conditional probability is. Okay, and I don't focus on the formula always, but I given a formula. This one is like conditional probability formula, and actually this particular one matters when you're discussing it about conditional probability. And the best way to visualize this conditional probability is all about Venn diagram. Now suppose this was universal set and this A and B. So okay, so in that probability we think like particular A event and B. So what is the this intersection point shows that how much they are impacted to other. Now suppose event A and B both event occur. This intersection between both of them shows that how much this particular both are similar to each other. Okay, so now suppose I will try to connect this particular one with recommending system Netflix. You understand much better. Okay, and Netflix recommending system conditional probability is just a puzzle, part of the puzzle. It's not entire conditional probability. It is a concept of the recommending system. So okay, so its intersection point shows that like uh, particular probability of A event A, when you are going to just predict B, then how much this both are dependent from each other. So that intersection shows that. Okay. Again, this particular conditional probability have a two different domains. Like the first one, dependent event. It's all about two particular event have a different far away from each other. Okay, it's look like something far away from each other. In that cases, we looked at how can we just manipulate there over there. It's like a dependent event, independent event. Sorry. Okay, so independent event like two different situation, two different events are farly different from each other. It's not a different. Okay, so that's the independent event. Okay, and in that case dependent events like two different events are close to each other. We have some intersection points, so that actually shows that uh, they both are related to each other. Okay, so that's the particular dependent event. So both are conditional probability, but uh, the boards deal with conditional probability but in different scenarios. Okay, so let me try to understand with a particular recommending system of Netflix, and which is based on probability. Let me consider a particular user who actually pick some movies and series. Let's suppose A. Okay, and after this one, the Netflix algorithm is designed by applying conditional probability to calculate how much the A related to other one in the databases. Okay, B, calculate B for recommending. Calculate B by conditional probability. It's all about something. It's look like something there. Now suppose this A, event A, which actually you pick some movies over there out of the different space, out per entire space of the movies and series, entire data points. Just pick one of them, and then Netflix recommend you something look like B, particular movies and series you selected, and this particular point shows like this particular movie you picked and that the particular one suggested you and how much they are similar. So that's the point. So that intersection point says that how much they both are similar. Okay, actually how much they both are similar. So that's the particular conditional probability want to say that. Okay, so that's the conditional probability is. And just you pick up movie and that they Netflix consider this particular event A, and calculating they try to calculate the event B. Okay, so by using the conditional probability, and just you suggest a lots of recommending, just recommend you lots of movies and series according to it. So that's all about, I think conditional probability is over now. And just little bit you should do that, we need to discuss idea first, and instead of mathematical formula, because of that all things work in your like idea. So we just focus on idea. like how actually this particular idea is appropriate for artificial intelligence, how they connect in real world scenarios to the real world application to understand much better about it. So when you're dealing with that kind of problem, you should to understand, you if you want to understand that how actually Netflix recommending system using AI. So that's not AI, but this is a simple prediction probability rule. Okay, we don't care if you want to just understand this one. So this is a simple probabilistic formula running behind a scene. Okay, so that's the people considered as AI, but that's the AI. AI is all about prediction and something all this. So that's the particular all about the conditional probabilities. And if you don't know what the conditional probability is, let's conditional probability is all about dependency of given likelihood, like how much the A and B events are interdependent from each other, how much they close to each other, how much they far away from each other. So that's the particular conditional probability is. Okay, again, if this particular one is going to productive for you, if you learn something from there, then it's my pleasure, and see you soon.